Let's talk about cis and trans as it relates to alkenes and the fact that depending on the alkene, you might have to add the prefix cis or trans so you can identify the configuration of the alkene. Now, firstly, cis and trans is not applied to every alkene. So let us establish the alkenes where you can use cis or trans. So for you to use cis or trans, you need to have one hydrogen on each carbon of the carbon-carbon double bond. Here's my carbon-carbon double bond. In order for you to use cis or trans, this carbon must have one hydrogen. This carbon must have one hydrogen. There's some other substituent here, and I'm going to look at a real example in a second. But I need you to remember, if you're going to use cis or trans, and in this case, this is cis, this carbon must have one hydrogen only. This carbon must have one hydrogen only. The fact that both hydrogens are placed on the same side of the carbon-carbon double bond, and this is what we mean by that. Here's the carbon-carbon double bond. Both hydrogens are above it because that's considered to them for them to be on the same side. This is cis. If I had both hydrogens at the bottom here, they're on the same side of the carbon-carbon double bond, still cis. Trans, remember, only one hydrogen. They must be on opposite sides. So here are my hydrogens. They're on opposite sides of the carbon-carbon double bond. One is above the carbon-carbon double bond, one is below the carbon-carbon double bond. So in order for you to use cis or trans, right, you need to have one hydrogen only on each one of the carbons of the double bond only. Notice I didn't show anything else here, just the carbon-carbon double bond. I needed to get that. Now, this is what we call a disubstituted alkene, and I'm going to show you an actual example. Disubstituted alkene. It's important you're able to recognize disubstituted because we're a tri and a tetrasubstituted alkene. You don't use cis or trans, use easy, which you can go look at that video. Now, let's look at a real example. Um, I drew both the structural and the line angle so we can look at both because there's something I need to highlight when it comes to your line angle structure. So here, first thing I'm going to establish that this alkene, you can use cis or trans. Here's my carbon-carbon double bond. I have only one hydrogen bonded to this carbon. So if you want, find the carbons of the double bond, make an asterisk to them or highlight them. I don't know, whatever works for you. Then, if I look at this carbon, there's only one hydrogen on it. There's this, and there's this group. This group is not a hydrogen. Go over to the carbon. Notice I didn't worry about what is double bonded. We're only looking at what's singly bonded. Singly bonded, I have only one hydrogen, right? Over this carbon, the other carbon of the carbon-carbon double bond, I only have one hydrogen. This is a CH3. We're looking at what is singly bonded, not the double bond portion. Okay, so this is a disubstituted alkene, right? So we're going to name it. So this alkene and this alkene, they're the same. This is a condensed structural and not a condensed structural, a partial structural formula, sorry, and this is a line angle, right? So let us name this alkene first and then we'll move over to here. I need to show you something on the line angle. So since your hydrogens are on opposite sides of the carbon-carbon double bond, one is above, one is below, this is going to be a configuration of trans, right? Then you need to find, of course, we talked about this in previous video, your longest chain of carbons in this molecule starts here. This is one carbon, two, three. Notice I didn't make a triangle. That's my longest chain of carbon here. That's a total of 1, 2, 3, 4, 5, 6. And I did not number in this direction because it would the double bond would not end up between 2 3. It would be between 1 2 3 4 5. It would be between 4 5. Okay, if you don't understand where that comes from, go back to naming alkene. So the name of this molecule is trans. My double bond is between carbon 2 and 3. You pick the lower number. 2 6 carbons in the longest chain. So it's trans 2-hexene. Same molecule over here, but I have a line angle. This is what I wanted to show you. I'm going to number the carbons just like in your partial structural, so you can see which carbon belongs to which. You should be able to convert a structural into a line by now, right? Carbon 1, 2, 3. So that's 1, that's 2, that's 3, 4, 5, 6. Whenever you're given a line angle formula, right, it's important that you figure out which direction your hydrogens are pointing, the ones on the carbons of the carbon-carbon double bond right here. Carbon 2, carbon 3. You need to put your hydrogens in. That's the only way you're going to be able to tell if it's cis or trans, right? Now, since the lines at carbon, the lines that make up your carbon and carbon 2, right? The two lines here meet, pointing down. The hydrogen on carbon 2 points down, right? Go to carbon 3. The bonds here meet pointing up. You notice this little thing is pointing up. This is definitely pointing down. So it's indicating to you the direction in which your hydrogen is in. So they're on opposite sides, above, below. So this is trans, the same molecule. Trans to hexene. And if you see trans X to E, that's also correct. Okay, cool. Let me show you how to identify a disubstituted alkene. This is what you do. Okay, so hold on to the fact that if you have only one hydrogen on each carbon of the carbon-carbon double bond, it is disubstituted. I want to show you another way how to identify a disubstituted alkene. It's going to come in handy when you have to identify tri or tetra. This is all you need to do. Find your carbon of the double bond and put an asterisk like we did before, right? So asterisk, asterisk. Then I want you to circle the bonds that are on the carbons of the carbon-carbon double bond. That is carbon number 2 and carbon 3. Circle the things that are the groups that are singly bonded to it. Notice I'm not doing anything over here, yes? Then go to your next carbon of the double bond, which is carbon 2, and circle the groups that are singly bonded. How many groups do I have that are not hydrogen? 1, 2. Therefore, this thing is disubstituted. It's not complicated. It's two groups that are not hydrogen. It's disubstituted alkene. Let's do one last example. Let's look at these two and let's name them. So firstly, we can apply cis and trans configuration. Each carbon of the double bond only has one hydrogen bonded to it, and I'm looking at the single bonds. This is a hydrogen, this is not. And these are the only two carbons of the double bond. Here's my other carbon, this is a hydrogen, this is not a hydrogen. So I definitely can apply cis and trans isomerism here. The fact that both hydrogens are above the ring. So here's my double bond. Both of my hydrogens are above the ring. They're on the same side. This is cis, right? Now let's do our longest chain of carbons here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. It doesn't matter which direction you number in here, you'll get the same. So it's 1, 2, 3, 4, 5, 6. It doesn't matter which direction you number in 1, 2, 3, 4. The double bond will still be between 3, 4, even if I go in the opposite direction. So your name here, cis, double bond is between 3 and 4. Pick the lower number 3. Here's a double bond between 3, 4. I pick the lower number 3. I have 6 carbons in my longest chain. So this is cis-3-hexene. I have the same molecule over here except it's in a line angle. Remember what I told you? Find the carbons of the double bond and you need to put on the hydrogen so you can know which direction the hydrogen point in. If both of them are above the ring, you know it's cis. So you putting in those hydrogens is crucial. It helps you determine the configuration. Both lines meet pointing up. Lines meet pointing up here, so they're both on the same side, right? Um, here, here, this little apex right here where the two lines meet point up. Here, here, point up. So we can now name this molecule. It's the same molecule. So 1, 2, 3, 4, 5, 6. I wanted to show you both line and structural. So to name, it's gonna be the same. Sorry, I forgot my configuration. The hydrogens are on the same side of the carbon-carbon double bond. Here's my carbon-carbon double bond. Both hydrogens are above. So this molecule is cis 3-hexene. If you have a tri or a tetrasubstituted alkene, you can't use cis or trans. You have to use E or Z. That is covered under the video that says easy nomenclature of alkenes.